Starting up soon. I got a note my mic fell off, but my mic appears to be on. Okay. So I'm ready to go.
I'll step up.
Okay. I don't know if I'm on. Jeff, can you hit? Should I just go? All right. Sorry for this strange beginning. I had a little note that my mic was off, but it's okay. Welcome to the next lecture of Lecture 8, for those keeping score at home, of Introductory Astronomy, the class you can get credit for, but apparently only if you attend Michigan Technological University. So if you're following these lectures and you're getting credit, you actually have enrolled, calling up and sending in your money, please send me email, because I think there's two audiences here. One is essentially the class, some of which is here in this classroom, many of which are at Michigan Tech but just watch the online lectures, and then there's another group, possibly larger, possibly significantly larger around the world, who is just watching the lectures as they come in. And I've gotten a bunch of email this past week about apparently learnoutloud.com no longer carries their these lectures in format that you can go to without going through iTunes. Apparently the way they were doing it, and I didn't really know this, was they were linking through iTunes. Deep linking, I think it's called. So they were using iTunes bandwidth. So iTunes decided they didn't like that. So they sent them a cease and desist order. So Learn Out Loud can't get these lectures through iTunes anymore. So in one sense, I'm flattered that we're either big enough or we happen to be noticed by the big players, iTunes and Learn Out Loud. But in the other sense, it's trying to restore those lectures to Learn Out Loud if they're willing to take them. So we're going to be working this week with people inside Michigan Tech, and there's at least one other university in Greece, strangely enough, who has volunteered to host the lectures. So we will see what happens with that. As usual, this is what is this question? So this is a strange-looking pizza-shaped object, and it has something to do with Jupiter or Uranus, and we will find out if you stay tuned. But what is going on here? The obligatory first of two slides, which tells you that we are taking introductory astronomy. Well, I'm sort of teaching it. And the call letters at Michigan Tech are PH1600. Today we will be going to the outer solar system, the biggest planet in the solar system, Jupiter, and we're going to skip over Saturn and go right to the next planet, Uranus. That's because if we try to do a Jupiter and Saturn lecture, if we go in orbit out to the outer solar system, both Jupiter and Saturn take up a lot of time because they're really interesting, and Uranus and Neptune are not as interesting. So I'm combining one interesting and one not as interesting planet. So next time we'll get to Saturn and Neptune. This is Michigan Tech. I am Robert Nemiroff. You can do these courses. You can get credit for these courses by going to courses.mtu.edu. You never have to see me in person. You can be offended over the internet. So what are you responsible for in this strange digital world? You're still responsible for the lecture material. You're responsible for the listed Wikipedia entries, which I give every week, but not the higher math if they go into higher math. You're responsible for the astronomy pictures of the day posted. For lectures that past week for the semester, anywhere from September to mid-December. If you want credit, you got to be taking the quizzes. To get the quizzes, you got to be enrolled at MTU and going to courses.mtu.edu, and then you will see it there. So if you're following along here in Michigan Tech, 1, 2, and 3 should have already been due. 4, I believe, is homework 4, quiz 4 also is due at same thing at 5 p.m. today. So if you're confused by that, come see me after class. So the Wikipedia entries you're responsible for this lecture are gas giant. I typed in Jovian giants, but Wikipedia redirected me to gas giant. So in general, we'll be looking at gas giants just briefly. Jupiter is the big gas giant we'll be looking at, and it's 4 Galilean moons. Jupiter has more moons. People keep thinking that asking how many moons of Jupiter is a really good quiz question or something, and it's not. And it's like knowing that will somehow tell people. There's new moons of Jupiter discovered all the time, and the rings of Jupiter's rings too, it's made of little bitty things. Each of those might be considered a moon. Same with Saturn. So the number of moons I'm not considering important for the Jovian planets. The Galilean satellites as discovered by Galileo. So if you have a small telescope, you get a whole bunch. For instance, you get to see craters on the moon, you get to see phases of Venus, and you also get to see the biggest 4 moons of Jupiter. 4 of the larger moons in the solar system: Io, Europa, Callisto, and Ganymede, which we'll be looking at. And then we'll be going out to see the strange case of the outer solar system planet Uranus. Okay, so the Jovian planets are Jupiter, Saturn, Uranus, Neptune, in order of planets out from the sun. So as you go out, as you might know by now, from the sun, you start with Mercury, the closest planet. This is not a Jovian planet. Then Venus, a hot planet, sort of Earth's twin. Then there's Earth. Then there's Mars. Then there's sort of a gap where there might have been a planet, but there's just the asteroid belt. Then there's Jupiter, Saturn, Uranus, and Neptune, and those are the planets. It used to be, when I taught this class 2 years ago, that I could call Pluto a planet, but now that's a controversial statement at best. It's a dwarf planet, and we'll talk about other dwarf planets later in this course. These Jovian planets, though, Jupiter, Saturn, Uranus, and Neptune, are large, massive planets. They are the largest planets in the solar system. Nearby civilizations passing by with their spacecraft would probably only note these planets, and they would be much harder to find out the existence of Earth than it would be to find out the existence of Jupiter, for instance. Each of these planets is known to have rings. Previously, 40 years ago, it was thought that only Saturn had rings, because Saturn has the biggest, most impressive ring system in the solar system. But they all do. There's many, many moons. How many? I don't care. The big ones I care about, and so should you. Expansive and thick gaseous atmospheres. So this is sometimes called the gas giants because of their thick atmospheres. So combined to their atmospheres, the rocky planets of the inner solar system have wimpy atmospheres. These guys have big, massive ones. So here's the relative sizes. So Jupiter is the largest planet known in the solar system. It is theoretically possible that there is a very large, very dark planet very far away from the sun, but it's thought to be unlikely. The dwarf planets they're finding out in the outer solar system are on the order of Jupiter and on the order of Pluto in size, which is significantly smaller than Jupiter. So most probably Jupiter is the largest planet around. Next is Saturn. In size, it has a ring system which goes out pretty far. These two are sort of considered similar. So the pairs of planets that are similar are Venus and Earth are pretty similar, Jupiter and Saturn are pretty similar, and Uranus and Neptune are pretty similar. And here they are there. So these make up the Jovian worlds. Okay. So let's look at Jupiter. As I keep saying, it is the largest planet around. It is 11 times the radius of the Earth. So you could throw the Earth into Jupiter, might take some strength, and Jupiter wouldn't really care. It wouldn't change all that much, most probably. It would just have Earth as part of it now. And Earth, Earth would break up and melt and just become part of the inner part of Jupiter. So Jupiter is so massive it doesn't really care about the Earth. Similarly, you could throw Earth into the Sun and it wouldn't be a big problem either. Its orbital radius, it orbits at 5 times, it orbits at 5 times, 5 times the radius of the Earth's orbit. So it's 5 times further out in the solar system. It takes 12 Earth years for one Jupiter year to occur. Okay, I'm going to cover these more on the next slide. The upper clouds. Jupiter's been visited by several spacecraft, and these include the Pioneer 11 and 12 in the 70s, the Voyager 1 and 2 spacecraft. The Galileo spacecraft actually took orbit around Jupiter and took lots of pictures. A lot of what we know is due to the Galileo spacecraft. The Cassini spacecraft on the way out to Saturn past Jupiter, and the New Horizons spacecraft on the route to Pluto and similar Kuiper Belt objects out in the very outer solar system also buzzed Jupiter on the way out. So we've had there's no people on these things. I was once asked, what astronauts, were on these. And there's no, these are robotic spacecraft. They get their programming from Earth. They're computer controlled. You can see Jupiter. Jupiter can become quite bright in the sky. Here it is on last July. So here's the band of the Milky Way galaxy. Here's Jupiter, nice and bright, hard to miss. I don't think you can see it reflected in the picturesque lake there. So here's Jupiter again. Images like this don't mean that Jupiter is a star or anything like that. Those are caused by the either by a digital effect put in by fancy Photoshop people, or the telescope. Many times this is taken by a telescope. There's holders that hold up the internal mirror, and these holders they deflect light. It's a quantum effect, and you can get an effect like that. So here you have Yellowstone, Old Faithful, spewing out lots of gaseous water vapor, and Jupiter is up in the sky there. So here's another indication that Jupiter can be quite bright. You can see Jupiter in the sky around now. It's very bright, low on the horizon. This is today's astronomy picture of the day. I actually had an interesting image, and here's Jupiter here. So it just happened to capture Jupiter. I happened to know about it. Oh, I wrote today's APOD. This is, we'll hear about it a little bit on Wednesday. This is Utah. These are big buttes and mesas in Utah. This is a stone circle that nobody knows if it's ancient or not. And here's, again, the band of our Milky Way galaxy. And there's Jupiter right here. Okay, in this image here you can see Venus gets even brighter than Jupiter. So if you want to go out and see Jupiter, it might not be. Venus usually, though, hangs close to the sun. So if you see something near the setting sun, or the sun has just set, and there's a very bright planet that's about to set right after it, good chance it's Venus, because Venus gets so bright. But if you see something later in the night, well after the sunset, and it's bright, there's a reasonable chance it's Jupiter, and that is Jupiter there. Again, this is Venus. This is the moon in crescent phase, and this is a star. This is an airplane. These are people. Okay, just so you know. So Jupiter's composition. It's got a rocky core, which takes about 10% of its radius. We don't know all that much about the inner workings of Jupiter because the clouds and upper layers are so thick we can't see down there. And Jupiter is so massive that it's hard to tell what's going on. It has a strange kind of metal that makes up 80% of its radius, made of metallic hydrogen, which is strange stuff, and we won't get into the details of it. Above that, though, it is thought that there's liquid hydrogen, and the impurities are thought to drop through Jupiter down toward the core. Above that, moving smoothly into the liquid phase, is the gaseous part of the atmosphere, the outer 1,000 kilometers or so. But it actually, knowing when you get into gas, since there's such a smooth transition, depends on your definition. It would be, this stuff is, you can't just land on. It's not metal like it would be a metal table. It would be a strange, degenerate material that you could not land on, you would sink into. So Jupiter has no clear core that we know of. Even if it has no clear surface that we know of, even if you go down to the core, which is likely rocky, it's probably hot and also probably molten, but no one's sure. There's probably no place to land on Jupiter. It's just there's different levels where it gets hotter and denser where you can melt and be crushed more easily. Jupiter's atmosphere we study mostly because it's the part we can see, although we don't even understand mostly what we're seeing. Jupiter is clearly mostly hydrogen and then helium. And one thing it's easy to measure is that it rotates in about 10 hours. It has dark and light zones known as zones and belts. And I always forget whether the dark ones are the belts or the dark ones are the zones. But one thing that's easy to watch is the giant hurricane-like systems that it has. In particular, there's one that's been going on for over 300 years called the Great Red Spot. And the Great Red Spot is a lot like a hurricane, but it's sort of actually an anti-hurricane. The hurricanes we have on Earth that get named are low-pressure systems, but this hurricane is a high-pressure system. Recently, and we'll see pictures, there have been 2 smaller red spots found. What turns the spots reds? Don't know. Why Jupiter has the colors it has, we don't really know. We're not clear what's doing that. So the hydrogen and helium that we're seeing is pretty much transparent. One thing that is clear is that Jupiter radiates more energy than it receives from the sun, which is strange. But it does not have fusion going on. It's thought that things are falling inside of Jupiter to make it essentially more and more centrally condensed, and that's causing the energy to be radiated. So even though it's this bright thing we can see at night, once again, there's stuff about it we just don't know. We don't know why it has its colors. We can't predict what colors it will have. We don't know really the details of why it radiates more energy than it receives from the sun. Here it is. One thing is clear, Jupiter looks cool. It's got a lot of texture. And here's the Great Red Spot, and here's some clouds that are affected by the Great Red Spot. And we'll see movies of this. These are white ovals, white spots sometimes. There's lots of these. They tend to come and go, sometimes on monthly bases or yearly basis. But the Great Red Spot, as I said, has been around for a long time, at least 300 years. Here's an approach to Jupiter. I think this might be Galileo. So here you can see the Great Red Spot rotates. And here you can see that clouds tend to go across. The storm systems tend to go across. There are bright regions here, dark regions there. The Great Red Spot is considered to be a soliton. It rotates in a single circle. Things that go in and near the Great Spot might be disrupted by it. You can watch swirling systems approach the Great Red Spot, sometimes to be destroyed. So it's a pretty stable storm system. Here's another red spot that was found a few years ago, sometimes called the Little Red Spot. Again, it wasn't there even a few years before that, so why it formed, we don't know. Here it is. It was thought it might be destroyed when it went near the Great Red Spot, but when it went by in July, it was found to have survived. If two weren't enough, a third red spot came about. And here, this one's going to try to make it through. Since being near the red spot, it's going to have to rotate through here, this one. And here you see, as of July, I don't have a more recent update of this. I think these pictures were taken, I don't know, they might be Hubble Space Telescope pictures. Here you can see, here's this red spot before this red spot, before the Great Red Spot having a good time. Great Red Spot was never in danger. This guy went too low, but it looks like, so Red Spot Junior looks like it survived, but this third red spot looks like it might not have survived. It might have been disrupted. So we'll have to see with more recent images when it's further away from the big Great Red Spot. The Cassini image, when it passed, Cassini spacecraft on its way to Saturn, when it passed Jupiter, took some very high detail. You can really see a lot of the tremendous detail in these clouds. Studying the clouds of Jupiter helps us understand how clouds and hurricane systems, work on Earth. So it's like a laboratory where you can see what happens many times. Whereas you can't take the Earth and put in new clouds and see what happens. Sometimes you can say, oh, here's a cloud system that has similarities to Earth. What happened on Jupiter when these things evolved? Here's another image of short loop where you can see things rotating. This was, whenever anything passes Jupiter, there's now an obligatory shot of the Great Red Spot if you can get it. So here is the New Horizons that's headed out to the outer solar system. This was taken in 2007 as it buzzed by Jupiter. It did not orbit it. It just went by really quickly. Took some pictures. Jupiter has rings. These rings are not as impressive as Saturn's rings. These rings are probably made of dust, much more dust and rocky material, broken up rocky material, than they are than Saturn's rings, which we will learn that Saturn's rings are mostly icy material. And here is I think this is a backlit image where the Voyager spacecraft that buzzed by Jupiter in the 80s was able to see these rings this ring particularly in great detail. Jupiter not only has rings, it also has aurora related to its magnetic field. Here you see both northern and southern aurora, and you see them on two different occasions. These are Hubble Space Telescope images. And these are old images. This is from '96, over a decade ago. Oh, yes. Back, was it '95? I have it as, it was recorded on an APOD in '95. So I guess that's when it might have happened. So there was a comet Shoemaker-Levy 9. I believe is the name of the comet. And this comet got caught by Jupiter and broke up. And people noticed it well ahead of time, and they were watching it quite closely, in particular Shoemaker and Levy, and it became clear that this comet, or these comet pieces, were going to impact on Jupiter. And now this was, again, way too small. This is much less than the mass of the Earth. It's not going to affect the orbit of Jupiter. It's not going to affect much, but they're going to fall into Jupiter, and we were very curious to see, well, what happened. I remember at that time I happened to be down at Marshall Space Flight Center collaborating on a gamma ray mission, and they were watching to see whether there were any gamma ray emissions when Shoemaker-Levy 9 hit Jupiter. There were none detectable that we could tell. But here you can see the spots left on Jupiter as the different big chunks of ice that were part of the comet fell onto Jupiter and were destroyed. Now, it's not uncommon for comets to be destroyed by massive objects. The sun destroys them routinely. At least several in a year fall into the sun and break up. But the sun's really bright, and they melt to a much larger degree. So it was very interesting to see these spots that I've circled here are no longer on Jupiter. They've gone away. So we can see things happen on the solar system, even on the time scale of the last 20 years. Things happen. Comets come and go. Here you can see some moons of Jupiter. We'll talk about the moons in a bit. You can see the part of the 10-hour rotation of Jupiter as it goes back and forth. Here you see the great red spot rotating. Actually, since this is upside down, it probably should be rotating this way. And these things here, this is a moon. That could be Io. Or that's actually more yellow. That could be Io. This could be Ganymede. Not sure. Okay, so let's talk about the moons. Jupiter has many moons. The most interesting are the four largest, as I said, found by Galileo with just a small telescope. Europa, Callisto, Ganymede, and Io. Europa has been looked at for a long time because it's thought that Europa might be frozen on the outside but have a liquid, chewy interior, such that there could be, if there's any liquid water in the solar system, people are very interested in it because you could have life swimming around in that water. So there could be fish. One person, actually, Freeman Dyson, once suggested, a famous scientist, suggested trying to look for frozen fish orbiting around Jupiter that used to be swimming in Europa. Then Europa was hit by some comet or something, and there was a big splash, and the big splash, breaking through the ice, would throw things out around Jupiter, and some of that might be fish. So I don't think it's been disproven, although I think the ice on Europa is now thought to be significantly thicker than people were hoping. But it is theoretically possible that there are frozen fish orbiting Jupiter. But we don't have any direct evidence of that. It's just fun speculation. Here you can see Jupiter and its four satellites, four Galilean satellites, are the brightest. You can see these with a small telescope. So if you go outside and you find Jupiter on the horizon, it's a piece of cake if you know where to look. You can just go to the web and print out an image. You can buy any astronomy magazine. They have some kind of center part where they have a picture. They just tell you where Jupiter is. Jupiter isn't always visible in the evening sky, but it's visible now in the evening sky if you're in the northern hemisphere. So just go out and look for it, and you can just see it just after the sun sets, and it's not cloudy. Sometimes it's in the morning sky. Sometimes not only it can be in the middle of the night sky. If you have binoculars, good binoculars, or if you have a telescope, you can pretty well see at least one of the Galilean moons, usually all four. They're not always on one side or the other. Here we see three on one side, one on the other. So here they are. This is a collage. This is never a single photograph. This is put together. None of the moons don't huddle this close. This just shows you how large they are compared to other things. So the largest moon is Ganymede. This is Ganymede here. The next one, I think, is Callisto. Then we have Io and Europa. Shows you the relative size. Our Earth's moon is roughly in the size scale of this. It's smaller than Ganymede, but they're roughly the size of Earth's moon. So let's look at Io. Io is really, really strange. For one thing, whenever you look at a moon in the solar system, you see craters. Well, when you look at Io, you don't see many or any obvious craters. What you do see is volcanoes. So now it's obvious in retrospect, but it wasn't really predicted beforehand. Io has lots of active volcanoes. So why is this? Why would Io have it and our moon not have so many active volcanoes? Well, the reason is that Io is continually flexed by the gravitational pull and tides of Jupiter. Well, Jupiter, of course, but Ganymede and Europa are the two large moons. And when they come near Io, they pull on it and they stretch it so that Io wants to go like this. And then in other circumstances, Io wants to go like that. And when you take something and you squish it like that, then there's lots of internal friction for the internal rock. And so that friction heats it up. So all of this flexing of Io makes it hot. And what happens when you get a hot rock? It wants to come out, and that's where you get the active volcano. So I've heard that Io is effectively turning itself inside out every few million years. So it's just continually turning itself inside out. The yellow color that you see for Io is caused by sulfur, but it's got many rocks. Here you see some ice. This hasn't had volcanic activity recently. Here you see a volcano active on the horizon. There's some areas that have probably recently had a volcanic explosion there. Here's the ring of a volcano. Okay, so here's two images of, this is a volcano here. And so the image was taken several years later by Galileo as it passed by Jupiter. And here you see the same volcano, but now you see there's something here, where there was nothing equivalently there before. Actually, you can probably see it right here. So this volcano became active and created this region. So this continually happens with Io. We continually see volcanoes going off and regions changed. So if you wanted to visit Io, you might want to stay on one of the colder regions, but even then I think that it's tough to have long-term real estate on Io because you keep getting lava covering you. Here you see another volcano, erupting volcano. You can see some of the plume over there. Okay, let's move to Europa. It's got the highest albedo. That means it's the most reflective. It's the most white of any of the Galilean moons of Jupiter. The interior of Europa is likely a little bit warm due to a little bit of tidal flexing like Io has, but not as much. Also, it has some radioactive heating, some radioactive substances, some of which heat the Earth. They also heat Europa, which might make the interior of Europa unusually warm, so it won't be frozen throughout. And if it has lots of ices, like these moons are made of mostly ice, then some of that ice will melt into water, particularly if it's water ice. So therefore, people hypothesize that there are water oceans with more. They hypothesize there are water oceans under Europa. Now, some people of those speculate that there could be life there. Now, we don't think, it's not a given. We're not sure there's life there, but it's a good possibility. And several science fiction authors, including Arthur C. Clarke, have taken up that possibility as well. Europa itself is mixed of frozen water ice and rock. And there are ice plates that move like Earth's tectonic plates. And I think we have some images there. So here you see Europa. It has all these cracks in it. Here you see an impact crater. Here you see a close-up of Europa again. There's lots of ice there. There's lots of cracks that go on in this ice, making it unusually textured. Again, another zoom in with a different color scheme. Okay, now here is the disconnected ice sheet surfaces, rafts sometimes they're called, on Europa. So what happens is you can see there are these boundaries of ice. And then you can see there's other ones. And just like a jigsaw puzzle, it turns out that you can take these and you can map them on. You can say, oh, this one belongs here, and this one was once connected there. So based on that, you can see that these things are shifting. So if they're shifting, one question is, what are they shifting on top of? So there might be tectonic activity on Europa, and that surface might be indicative of there might be liquid water under there that's helping the tectonic activity. Ganymede, largest moon in the solar system. It's larger than the planet Mercury. So if we were to take Ganymede and put it near Mercury, we'd say, oh, look, a planet. But since it's orbiting a moon, since it's orbiting the planet Jupiter, which is clearly a planet, it doesn't get a planetary designation. And this shows you that determining what a planet is isn't always so straightforward. There isn't this class of objects that's really big, so we call them planets. And this other class of objects that's really small, so we call them moons. And then there's other classes of objects that are even smaller than that we call asteroids or comets. No, it's more complicated. There are moons that are bigger than planets, real planets. So Ganymede is bigger than Mercury. It's, however, much less dense than Mercury. Mercury is a lot of rock, and Ganymede is some rock, but lots of frozen water, too. Ganymede has strange grooved terrain that is younger than most of the impact craters, and we don't know why. Here's an image of Ganymede, which shows where there are certain minerals based on their reflectivity. Here's a flyby. When Galileo flew by, Galileo orbited Jupiter for a while, and it got to fly by many of the moons, including all of the Galilean moons. And so based on computer reconstructions, this is an image of what the surface of Ganymede would look like. So it's kind of bumpy. It's not as smooth as if you picture ice, you might picture an ice rink, and people, if they land there, could just go skating. But at least on the scale of kilometers, it's not like that. Callisto. Callisto looks like a giant smashed ice ball. It's dark. Its albedo is low. It's covered in ice. It has lots of impact craters. It apparently is not getting flexed as much as Io. However, it might be getting flexed enough to have very deep under its surface some oceans as well. It has been suggested. Very few craters are smaller than 100 meters across. And it said possibly very deep inside there are oceans. Here's a picture of Callisto. Again, it's massive enough to become a sphere. It's dark, unusually dark, and all of these things were impacts. Instead of making nice, clear, like our moon, which doesn't have much ice, if any ice at all, on its surface, this is like a big crystal ball, but it's a crystal ball that keeps getting rocks and stuff rained on it. And whenever it gets smashed, then you see a smashed pattern. So you see lots of smashed patterns on Callisto. Okay. So that's essentially what you need to know about Jupiter and its major moons. So now we're going to jump over Saturn to come back to it next time, as I said, and go out to the next major planet in the solar system, which is called Uranus. And so Uranus is one of I guess the butt of jokes, one might say, for its name, which might be called Uranus, but I prefer the Uranus. My favorite joke about, so there's lots of jokes about the name, is when somebody says things like there's rings around, Uranus, instead of pointing out the obviousness of the joke, I like to just say, excuse me. And that, so if someone says that, you can respond similarly. I have not copyrighted that. So Uranus has a twin in the solar system. It's Neptune. So they're very similar in size and mass. Uranus is slightly larger, I believe, and slightly closer. It's 4 times the size of the Earth. Uranus has a very strange spin axis. Oh, excuse me. It's tilted sometimes directly toward the sun, so this is your basic sun, and this is your basic U planet. Sometimes the rings will be, and its spin axis will be toward us, and sometimes it'll be directly toward the sun. Its orbital radius is 19 times that of the Earth, so it's 19 times further out in the solar system than the Earth. It takes 84 years to go all the way around. Uranus has many small rings and moons, and its atmosphere is almost featureless. It's very smooth. You have to image it in different kinds of light in order to pick out any features at all. It was passed by a spacecraft. It was passed by the Voyager 2 spacecraft in 1986, and that is the only spacecraft that has passed it. Uranus has an unusual composition. It's got a rocky core, which goes out to about 20% of its radius. In the middle mantle, again, it doesn't really have a rocky surface you could land on. It has a hot, dense, fluid surface, probably made of ices, of water, ammonia, methane, possibly too hot to contain life. That goes out to 80% of its radius and contains most of Uranus's mass. So its atmosphere, which is the latter 20% of its radius, actually has relatively little mass, but is composed mostly of hydrogen and helium. Here it is. It's blue. It's not fun to look at. It's a big blue sphere in the outer solar system, sometimes called the tilted planet. Again, this was, I think Voyager passed it in the 80s, but this image was rerun on APOD in the 1990s, and it's called the tilted planet because its spin axis can sometimes point to the sun, whereas the Earth's spin axis points pretty much to the north. Always points to the north, but it points out of the ecliptic plane. Uranus's spin axis can point in the ecliptic plane, in the orbiting plane of the planets. So if you look at it in just the right colors, I think this was taken with the Hubble Space Telescope, you can see that Uranus does have some oval storm features, and it even has some bands. It even has rings. Here you see the rings at 2 different times. Zooming in, here you see the rings is taken by, again, earlier on. I guess this was, here you see Uranus has several rings. I'm not quite sure. This must have been taken by the Voyager spacecraft. The rings of Uranus are also sometimes detected by the Earth when the planet moves in front of a background star. Uranus actually is detectable by the unaided eye. It's just on the edge of visibility. If you know exactly where to look for it, you can. But it wasn't recognized as a planet until maybe a little more than, well, close to, 150 years ago or so, if I recall correctly. People saw it, and they kept thinking that it was either a star, they would give it a star name, or they would think it was a comet, and they'd investigate it, but it was soon realized that it was neither of those, that it was actually a planet. The planet was then named for King of England, but the people who don't live in England or are not protected by England didn't like that. So it was renamed for a god or goddess, which in this case I think was a parent of Saturn, which is the pattern Jupiter, and given the name Uranus. Many moons, none of them as big and massive as the Galilean satellites. So Uranus has smaller moons. I believe the largest is Titania, I think Oberon's the largest, then Titania, and then Umbra, which is not that bright, and then Ariel. Miranda's pretty interesting. Here you can see the rings in this image pretty clearly. Lots of smaller ones, harder to see. Probably a background star. This is the moon Miranda that was passed by Voyager. You can see it has craters, like many moons. It's probably composed of ice. This jagged feature is not real. This is just the amount of imaging that was able to be done by Voyager as it passed by. Miranda has unusual grooved terrain, the origin of which isn't always clear, large craters, also some unusual cliffs. Here we see a very large cliff, many kilometers. I think this is around 8 kilometers or so, maybe more, is known as the tallest cliff in the solar system on Uranus's moon, Miranda. So there's unusual features out in the solar system. It would be this is one of the things where the gravity is so low that it might be possible, if you had the right kind of spacesuit with lots of inflatable, like balloon type spacesuit, you might be able to jump off of here and joyride down to the bottom of the 8-kilometer cliff. It'll probably take a small jetpack to fly up the cliff. Which brings us back to what this is. So now, the first image we're now able to see in some detail, this is Io, one of the strangest moons in the solar system, one of the Galilean satellites of Jupiter, the innermost of the Galilean satellites. This is Io in true color. Here we can see that many of the Ios, the sulfur color, it looks very strange. The light ices, the volcanic places where all the planets, all the many numerous volcanoes that are just all over the place on this very unusual volcanic moon. So run through this quicker than I thought, but we'll end a little bit early today. Next time we will do not only Saturn and Neptune, but we will go through the last 7 astronomy pictures of the day, including one I showed you today. So back out to the outer solar system next time. See you then.